Sometimes it's better to look at space from space.
And sometimes it's better to look at Earth from space.
But can the same kind of technologies used to discover black holes and distant galaxies be used to teach us more about our own home in the universe?
And can it help us explore new frontiers of space?
You betcha. I'm Jennifer Pulley.
And I'm Johnny Alonzo.
On today's NASA 360, we're going to take space exploration full circle. From the amazing discoveries of deep space back down to Earth, where scientists are using those same optics to look at our home planet in ways we've never explored before.
And to prove that there's always something new to discover, especially where you least expect it, I'm going behind the scenes at NASA's Jet Propulsion Lab to find out what's happening on Mars.
But we can't talk about discoveries in space without talking about NASA's most prolific scientific tool to date, the Hubble Space Telescope.
First of all, no self-respecting Earthling should ever go without knowing a little bit about the Hubble Space Telescope. Why? Well, the Hubble Space Telescope has revealed more to us about space in the past 10 years than we've ever known about the universe. Ever. And it's the direct solution to a problem these telescopes have faced since the earliest days of their invention: the atmosphere. See, observing space from space has revealed some pretty significant things. It allowed us to measure the age of the universe. It confirmed that every large galaxy has a massive black hole at its center, and it was key to the discovery of the role of dark energy, just to name a few. But what does that mean to us here on Earth? Well, the more we study the composition of the universe, the more it reveals how it and we came to be. Hey, you want to see how Hubble works? Check this out.
This is the Hubble Space Telescope Operations Control Center. And this is Keith Wallace.
Hi, Jennifer.
How are you, Keith?
Great, how are you today?
Great. He's going to give us a behind-the-scenes look at the brain center of the Hubble Space Telescope.
You want to take a look inside?
Yes.
Come on. Come on in.
So, Keith, what's going on in here?
Well, this is the Hubble Space Telescope Control Center. And from here, this is where we command the telescope. And by commanding the telescope, we're going to tell it where to point, which pictures to take, when to send the data back down to Earth. And the pictures that you see, they're not really pictures that we're taking on board. They're just computers taking pictures, but they're different kind of pictures. When we look at something, we look in visible light. But we don't just look in visible light. Hubble also takes pictures in near infrared, kind of like those night scopes that you see. We also take pictures in ultraviolet. We also have cameras which aren't exactly cameras, but they're more like spectrographs. It's like a prism. It breaks the data down into all the different beams, and then we study from there. So we actually have 5 cameras on board taking pictures, not just one, sending the data down. And the data is going to come down here to Earth. It's going to come through our control center, and then we're going to send it up to the Space Telescope Science Institute in Baltimore. And from there, they're going to disseminate the data and send it out, and people are going to look at it on the web, in the newspaper, and all different places.
So, Keith, who decides what Hubble should be looking at?
Well, that's tough because it's a very popular telescope to use. In fact, so many people want to use it that only 1 in 7 actually get to use it at any given time. And it's peer-reviewed. You'll have a group of scientists, professors looking at the different proposals coming in, and they'll decide which ones get that very valuable time on Hubble.
There's so much space out there and so little time, huh?
Yeah, fortunately we have quite a few different cameras and optics on board. In fact, you want to go over to the clean room and see some of them?
I would love to do that.
Well, we're going to need to get you in a bunny suit first.
Bunny? As in rabbit?
If you like, but I was thinking more of a clean suit, and we just call them bunny suits, and you'll see why when you get into one.
You know, without NASA, bunny suits wouldn't be what they are today. After a little research, NASA found out that the greatest source of contamination in clean rooms came from workers, and this is because microscopic body particles could actually find their way through the tiny windows in woven garments. Using that data, Tyvek was created. It's non-woven, and it filters 99% of all particulate matter. We're talking the small stuff, guys. Today, bunny suits are used in hospitals. They're used in the clean rooms of computer companies, as well as in situations where we need to be protected. Gloves are next, I think. Oh, I'm ready. I'm clean.
Well,
Welcome to the world's largest clean room.
This is amazing, right?
And the reason we have this exact mechanical replication of it, we need something that looks just like Hubble, functions just like Hubble, so everybody can see what it really looks like when they get up there to work on it.
So Mike, Hubble has more than one instrument.
Right, it has actually 5 instruments, 2 types of cameras. Imaging cameras, which take all those beautiful, pretty pictures that you see, and spectrographs. Spectrographs are the types that put the physics and astrophysics. They measure all the physical properties of the things we're looking at.
So what about those images? They are stunning, but what do astrophysicists know what they're looking at? So what about all those amazing images from Hubble, like this one here? To me and my untrained eye, this looks like a falling star.
Hi, Jennifer, that's a very good guess, except for the fact that it's not just a tiny little point of light. It's actually got a lot of extension and fuzz around it. This is a Hubble image of a comet, which is a body that was created at the very early beginnings of our solar system.
This is amazing, but you know, it leaves me with this question. I mean, how do astrophysicists like yourself take this data and then turn it into a meaningful image or even a plausible theory?
Well, it's actually not as complicated as it may seem. Hubble, while a very, very expensive, fancy instrument above the in Earth orbit, is using a camera that's very much like the electronic camera you have at home. So think of a megapixel camera. This is about 1,024 pixels along this direction, another 1,000 along this direction. And it's taking snapshots. And if we know how far this object, how far away it is from us, and we can figure out how much light is in each little box, each little pixel of this image, we can figure out how big and how bright the thing is that we're looking at.
So, Kerry, looking at space from space is truly the way to go.
Oh, absolutely. When you're above the atmosphere, you have none of the blurring effects. Everything is crystal clear. The Hubble images of this comet, for example, we can see things as small as 10 meters across.
Thank you so much, Dr. Liss.
It's been a pleasure. Thank you.
Well, as you can see, telescopes in space are finding the building blocks of life out there in the universe. But can they tell time? Can they predict tomorrow's forecast? Yeah, actually, they can. Stick around and you'll find out how. You're watching NASA 360.
Beach has got to be one of my favorite places on the planet. You know, this is where I can see 3 things I can't live without, or we can't live without: the sun, the sky, and the ocean. And I'm not just talking aesthetics here. See, the pure science of how these 3 things interact, it's huge. That's why NASA has made studying that dynamic a priority. And that's why right now, Jennifer Pulley is making it a priority. Jennifer.
The Earth and the sun, they have a beautiful relationship. Okay, I know that there are several other planets out there that also place the sun in the center of their existence, but Earth and sun have something pretty special going on. In fact, the only thing that comes in between the two is the Earth's atmosphere. And actually, that's a good thing. Because beyond the Earth's protective layers is the exotic outer atmosphere of the sun, known as the heliosphere. Now, the heliosphere is full of ionized atoms, magnetic fields, and much more, all moving about in every direction at about 1,000,000 miles an hour. That's the stuff our Earth's atmosphere is constantly interacting with. And it's mostly unpredictable. More than ever, it's causing major problems with technology, like cell phones, GPS positioning, and satellites. To get a grasp on what's going on up there, NASA has sent a satellite to one of the least explored regions of the Earth's atmosphere. Think of it as the final frontier of the Earth, except in the sky. So what exactly are scientists looking at?
Thermosphere, ionosphere, mesosphere, energetics, and dynamics.
Otherwise known as timed.
Yes.
Guys, this is Dr. El-Sayed Talat, and he's studying the final frontier of the Earth, which is the thermosphere, ionosphere, mesosphere. It's the final frontier of the Earth's atmosphere, right? Why study this region?
Well, it's the interface and buffer region of the Earth's atmosphere. It's where the sun's energy is first deposited into the atmosphere, and it's where the atmosphere interacts with the near space environment.
So scientists have known for years that the sun impacts the Earth, right? Okay, so what else is there to learn? What's changed?
Well, we've never made a really good exploration of this part of the atmosphere. We've only had sporadic measurements over the years. And so TIMED is the first global exploration of this region of the atmosphere. And TIMED is providing scientists all around the world with the first basic understanding of the natural processes that affect this part of the atmosphere and human activities that may affect it as well.
Okay, so we've learned about the TIM of timed. We're left with ED, energetics and dynamics. Explain that.
Well, we're studying the energy transfer in and out of this region of the atmosphere and the dynamics that result from the energy being put into the part of this atmosphere.
So the research you're doing today with timed will hopefully keep us one day from never having to say, can you hear me now? Can you hear me now? Hello, hello, right?
All right.
Thank you so much, Dr.
Thank you.
Talat. Appreciate it.
Before we jump into a discussion about the ocean, I want to talk to you about my sunglasses. They're probably no different than yours, but did you know that a lot of NASA know-how was taken by the sunglass industry to make these? Yeah, it's called a technology spin-off. First, polarized lenses. They filter out the harmful UV rays and prevent glare, especially when you're surfing and skating. And without the research NASA did on human optics, we'd be forever squinting. Ouch. Not good. Second, scratch-proof lenses. Now these days, all lenses are plastic, but they're stronger than ever because of a protective coating originally designed to protect spacecraft from the harsh environments of space. But can they resist the diamond-like strength of sand at the beach? We'll never find out in this episode. Not with my shades, at least. Okay, so yeah, it's true. Yes, I'm a surf fanatic. I love the beach. But I know that there's more to the beach than just a killer set of waves. Yeah, the ocean's it's a living organism, and when it changes, life on Earth changes. And no one knows more about that than this guy right here. What's going on, bro?
Hey.
How you doing?
I'm good. How's it going?
Good. This is Dr. Josh Willis, an oceanographer at NASA. Wait. Oceanographer at NASA. I didn't know that NASA studies the oceans.
Yeah, that's right. NASA, of course, studies everything in the solar system, and it flies some really important satellites. And satellites are one of the best ways to look at the ocean.
Really?
It's really only from space that you can see the whole ocean all at once. So we have lots of really important satellites like Jason 2, that actually measure the height of the ocean from 800 miles in space. And they can measure it with the accuracy of about an inch. That's about the size of a quarter from 800 miles in space.
So obviously this is one watery planet.
Remember, 70% of the Earth is covered with ocean. And it turns out that as the planet heats up, as we trap extra heat here on the Earth, 80 to 90% of it winds up going in the ocean. Now that heats up the water, and when the water heats up, it expands. It actually gets taller. So adding heat to the ocean makes the sea level rise because the ocean just takes up more room. So for instance, coral reefs, many coral reefs live in a very narrow range of temperatures, and if it goes outside that, the reef can die. And of course, if the reef dies, lots and lots of fisheries, lots and lots of other animals and marine life dies along with it.
So NASA sent a satellite to study the oceans. I mean, what's it exactly doing?
Well, I tell you, what you really need to do is go see my friend Bill at the Jet Propulsion Laboratory. Bill Patzert, he knows all about this stuff, and quite honestly, I gotta work on my tan, man. Look at the time, I gotta get out of here.
I put this guy in the show and let's see what I get. Faizan, I'll talk to you soon, all right? Be good. Thank you, Doc. Yeah, right on. Hey, Dr. Patzert. Hey, Josh sent me.
Hey, Johnny.
Yeah, how you doing? Right on, dude. Listen, I heard you're a surfer.
Well, you know, I'm an old surfer, you know, not a young surfer like you.
But it's cool, but listen, as a surfer, you know, I'm like one of your most humble students of the oceans today, all right? Can you tell me what OSTM Jason 2 is telling us about the oceans?
Well, this is a great series of missions that's been flying for almost 15 years now, and we're mapping the heat and the height of the ocean. And this is very powerful information, Johnny.
So what's the Pacific Ocean telling us?
There is a very large signal out there, Johnny.
Yeah.
As CO2 has increased over the past century, the response in the Pacific has been dramatic. Sea level has risen almost 8 inches in the last 100 years. And so really, it's the unequivocal proof of global warming. And so the question really for civilizations all across the planet is, what impact will this have on normal climate and weather systems? Because we're definitely living in a warmer world of higher sea levels, and it's more than just beaches disappearing. It's going to be a fundamental shift in climate systems and will have a powerful impact on civilizations, not only in the United States, but everywhere on the planet.
Now, one way to study the importance of water to a planet is to study another planet that has water, or some form of it. Hey, stay tuned, because NASA 360 is taking everything you've learned full circle. The more we learn about space, the more we learn about the origin and composition of space. And that helps us understand the origin and composition of the Earth. So how is all that knowledge being used together? Well, we need to look no further than one of our closest neighbors in the solar system, Mars.
It's red, it's rocky, and apparently it's full of water. To understand how water could exist on a planet like Mars, scientists study the minerals that are left behind after it evaporates. It's kind of like doing investigative forensic work, but without being able to set foot on the scene of the crime. It requires some very special tools, not to mention a scientist with a very keen eye. And one of those is Dr. Deborah Buchkowski. Hi, Deborah.
Hi, Jen.
Okay, so let me make sure I have this straight. Your job is to analyze pictures of water that's evaporated.
To use your forensics analogy, it's like we're looking for the spectral fingerprint of minerals that might have formed in water. And we can then use that and look at these minerals to determine how long that water might have been there, where it might have come from, and even whether or not there might have been life there at one point.
You mentioned spectral fingerprints. What does that mean?
We've all seen rainbows. We've probably all in science class done something with a prism where we broke up sunlight into many different colors.
Right.
What most people don't know, though, is there's more than those 6 colors: red, orange, yellow, green, blue, violet. But our eyes can't necessarily see all these hundreds of colors. However, we can make instruments and machines that can pick out all these colors. And some of those colors are particularly indicative of certain minerals, especially minerals that formed in water.
And all this investigative work, I mean, finding out about if water was on Mars, how long it's been there. What does this tell us, and why do we care?
Well, it's not enough to know that there was once water flowing on the surface of Mars. Just by looking at certain features on Mars, we could actually tell that there might have been some kind of liquid flowing on the surface, especially right here in this region, where there are things that look like riverbeds, or in here, this whole region resembles parts of the Earth where there have been catastrophic floods.
You know, Deborah, I have a feeling that what we find out about the history of Mars can only give us insight into our own planet. Thank you so much.
You're welcome.
One of CRISM's recent accomplishments was helping to find the perfect landing spot for a new Mars visitor. One that is currently on the surface of Mars, scooping up those minerals we were just talking about, and discovering water.
NASA's Phoenix mission to Mars definitely caught the world's attention. I mean, discovering water on Mars, man, it's incredible. But before the Phoenix mission, there were the Mars Rovers, NASA's twin robot geologists. They have wheels to get around, cameras to see. They even have robotic arms to pick up samples. It's almost like having humans up there. So what does it take to build a rover like that? Follow me. There she is. Just the person I was looking for. Jessica, how are you?
See you.
Good to see you. She worked as an engineer on the Mars Rover project. All right, so building something like this, I mean, it's there's a lot of elements to consider.
Right.
What does it take to build something that's almost human-like?
Well, that's a very good point. You know, we aren't sending humans to Mars right now,
Right.
and we need to build a spacecraft to go explore in the same sense that we would explore ourselves. So we need to think about visuals. How are we going to decide where we're going to go? We need to be mobile. We need to have a mobility system to be able to drive around for the rover case. So we have these cameras that we're able to span out across the horizon, pick our next target. We have an autonomous navigation system which allows us to drive with no instructions throughout the day. We just pick that target, drive off to that area. We have solar panels that allow us to keep charging every day so that we can run as long as the soil will allow us. You need to think about the way that you communicate back to Earth. So we have our antenna system, our telecom system, and then you need to think about, well, what's the science that you're doing? And so, just like a geologist in their, tool belt has all these different types of instruments, we pack them on our robotic arm on our rover.
Sure.
So if you can imagine the robotic arm, just like a human arm, shoulder joint, elbow, wrist, and then the hand is a collection of, in this case, 4 different types of devices.
Jessica, what's next for Mars?
Right, so we have the two of these rovers that are currently on Mars, the Phoenix landed mission, and what we're working on next is a rover that's probably about twice the size of this rover. And what we'll be able to do with that is, with a bigger mobility system, a bigger engineering mobile type package to get around Mars, we'll be able to go to those interesting places that are even further from where we land.
Thanks a lot. Although the technology is mind-blowing, the star of the show, the reason the arm works so hard, it's all about the water. All right, so we're here at the Mars Area with Dr. Ashwin Vasavada. I mean, it's a simulation of Mars. It's very dry and rocky. Dude, are you sure there's water on Mars?
That's a good question. I mean, you wouldn't think so if you looked at this.
No.
And in fact, a lot of Mars today looks just like this. But the key is that when we look at Mars from orbit with instruments like XRISM and other big high-resolution cameras that we have in orbit, we can tell that a few billion years ago, perhaps, in ancient, early Mars history, it looks like there's water all over the place. We see evidence for rivers that are now dry, see evidence for maybe shorelines of ancient oceans, lakes that are no longer there, and that's the kind of place we want to target with the Mars Science Laboratory. Go to one of those places and try to figure out what exactly the environment was like a few billion years ago.
So what are we learning up there that's going to help us down here?
Well, I think the thing to keep in mind is that Mars and Earth are more alike than they are different.
Okay.
In fact, we consider Mars the most Earth-like planet in the solar system. So we're going to have a team of about 200 scientists working on this mission when we actually land.
So what kind of tools does the Mars Science Lab use?
Well, what we really want to do is study the rocks and soil. Because if there's any clues to what Mars was like a few billion years ago, the clues are going to be in the rocks and soil. So we have a rover that can drive around up to a rock it thinks it looks interesting, or a patch of soil it finds really interesting. And we drive up to it, and then we can scoop up some of that soil, or we can drill into the rock and capture some powder from the inside of that rock, and actually deliver it to the rover itself. And we have some fairly big scientific instruments inside the rover that can study the chemistry of that sample and look basically for clues of whether water was there in the past, or what the temperatures were like, or other hazards or things that are good for life.
Thanks a lot, Doc.
You bet.
Right on. Hey, we've covered a lot of territory today, but you know what's cool and exciting? The process of how we're learning. And yeah, man, science is a process. But you know, now more than ever, the sciences are interdisciplinary, meaning the astrophysicists are working with the geologists, who are working with the oceanographers, who are working with the astronomers. You see how it all comes full circle? That's it for this episode. For Jennifer Pulley, I'm Johnny Alonso. Catch you next time on NASA 360.
To understand how water might exist on a planet like Mars, scientists need to study the phone.
I want to show you something. What do you think?
Cell phones, GPS satellites, and yeah.
Sunglasses are a NASA spin-off. How do I look?
I should walk off right now. It's red. It's rocky. Oh, thanks, Christina. Oh, apparently it's full of water. And I'm Johnny Alonso.
And I'm Jennifer Pulley. Oh, she's gonna hate me for that. I swear she's gonna kill me. I'm done.